Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be going over 5.2, which is complex numbers, specifically complex number operations. If you recall from way back in Integrated Math 1 or even in 8th grade, we talk about the number system, and we have a whole category of numbers. We separate those into real and imaginary, and at the time we sort of ignored those imaginary numbers. And the real numbers we broke down into rational and irrational, and rational numbers broken down into integers or whole numbers, and that's further broken down into the natural or counting numbers. But that whole number system together is what we refer to as the complex number system. So complex numbers, specifically in this case, are having real and imaginary parts. And so when we are doing operations with complex numbers, we're going to treat those different parts, if you will, as like terms. So here's what this looks like. So let's say I have something like 4 plus 3i. Okay. We're treating both of these parts as though they were different terms. So 4 as a whole number and an integer obviously is a real number. And 3i, because it has the I, is the imaginary part. So together, having these two parts, that's what we refer to as a complex number. It's containing both real and imaginary parts. So you're asked to do three things in this section. One is to add complex numbers. One is to subtract complex numbers, and one is to multiply complex numbers. So once you do this, it starts sinking in. Let's say I have something like 3 plus 2i plus 4 plus 5i. So all you have to do to add complex numbers is add the like terms or like parts. So 3 plus 4 would give me 7, and 2 plus 5 would give me 7i. So I'm treating the imaginary parts as like terms, and then I'm treating the real parts as like terms. So 3 plus 4 gave me 7, and 2i plus 5i gave me 7i. That's all you have to do, and that's the majority of your assignment in this 5.2 assignment. Pretty simple. So 6 minus 2i plus 3 plus 4i. So as always, you just want to be careful when you're combining like terms, and especially if there's different signs involved. But 6 plus 3 gives me 9. And negative 2i plus 4i gives me 2i. Number 3, let's do 5 minus 4i minus 3 plus 6i. So want to be careful with our operations here and our signs. This is subtraction, so I'm doing 5 minus 3, and then negative 4i minus a 6i. So that would give me 2 minus 10i. And you can do an infinite number of these. Most students are comfortable doing that once they recognize that they're like terms. You just add and subtract, being careful with your signs. Multiplication's a little bit different. So let's do an example here. Let's say 3 plus 5i times 2 minus i. So because we're treating the real and imaginary parts as different terms, here this is like if we were multiplying a binomial times a binomial, going back to units 3 and 4. So this is up to you how you want to do it, if you like the box method or prefer the box method, or if you just do FOIL. I personally do FOIL, so you're doing 3 times 2, and then 3 times negative I, and 5i times 2, and 5i times negative I, which would give you negative 5i squared. Once you do that, you're going to combine your like terms, so negative 3 plus 10, which would give you 6 plus 7i minus 5i squared. Now, if this was just a quadratic equation, we'd be done, right? We combined the two middle terms, and this is what we got. However, if you will remember from your definition of I, that I is the square root of negative 1. Therefore, I squared, by squaring both sides, is -1. So what we would do here as our last step is replace that I squared with a -1. -5 times -1 would give me a +5. And now we can combine 6 and 5 to get 11 plus 7i. So in the multiplication process, you should end up with a complex number with one real and one imaginary part. So the very last step, you need to multiply, or when you get that I squared, you need to change it to be -1. Let's do one more, number 5. Let's do -6 plus 4i times 3 plus 2i. So same thing, do your FOIL, -6 times 3, -6 times 2i, 4i times 3, and 4i times 2i. Now, it just so happened in this example that I ended up with the same middle terms, which is fine. -12i plus 12i is 0, right? That leaves me with -18 plus 8i squared. From our definition of I squared, we're going to convert that to -1, which means my final answer is -26. Now, I just got done saying that you need to have a real and imaginary part, but it's possible that once you simplify, your imaginary part is 0. So that 0i is optional. You don't have to write it. It's possible that when you do simplify, you end up with just the real part, just the imaginary part. You can include that if you want, if it helps you remember, but you don't have to. That's all for this lesson. If you have questions, please attend office hours or reach out to me. Otherwise, have a good day, and I will talk to you guys soon. Bye.